Today we're looking at the ultimate polynomial question, which is long division. Sometimes you have to do division when you can't factorize it. You have to work your way through from left to right and slowly break down a polynomial. And the way you do this works exactly the same as you would do if you're dividing a larger number by a smaller number. Now, the notation that people use is different from different countries, but I'm going to write it out how I do it, and I can imagine you would do it slightly differently. But I would write down the big number I'm dividing into, and the number I'm dividing by goes on the outside of some sort of symbols. You might have a line underneath. But then you work your way from left to right, and you see how many times this number will fit into this number. And the way we do this algorithm that we use, there's lots of shortcuts that you don't even think about it because you've done it so many times. But there is a certain process going on here. That 3 will not go into the 1, but that 3 will go into the 15 5 times. But actually, that's not representing 5, that's representing 500 because it's in the hundreds column above this number. And so what I'm going to do is I'm going to subtract away 500 times 3, which would leave me with the 72. Usually we don't even bother writing this, we don't need to. But then I would do 3 going into 7, which goes twice. And that's not really representing 2, it's representing 20. It's in the tens column of this number here. And so what I'm doing here is I'm subtracting away 60, which leaves me with 12. And here I have 1 left over because it only went in twice into the 7, so there was 1 remaining. So then I'm looking at 3s and going into 12, and that goes in 4 times. And 3 times 4, that's in the units column, so that is representing 4 lots of 3. And so I'm subtracting away 12, leaving with a remainder of nothing. Now normally I wouldn't bother writing that bit down, but this is the process that I'm actually going through. And this is the process we're going to use when we're dividing polynomials. I could do it in almost exactly the same way. I put the bigger expression underneath the symbol. So this is 2a cubed plus 4a squared b plus 4ab squared plus 2b cubed. I'm dividing by a plus b. There is no obvious pattern that I can quickly work out the answer, but I can, just like I did with the numbers here, I can go from left to right and see how many times this expression fits into here. And I'm just going to focus on the a's to begin with. If I want to make that match this, I would have to multiply this by 2a squared. And it fits into this expression 2a squared times. The b doesn't really matter, we're going to use that. But just like I fitted this into here 5 times, I then had to subtract away this times this, the 15 gets subtracted away, even though you don't necessarily write that. But that is what you have to do here. So 5 times 3 is 15. 2a squared times a plus b gives me 2a cubed, and multiplied by the b as well, I get 2a squared b. So you look to see how many times that fits into here, or what do you have to multiply this by to make this match. So I have to multiply this by 2a squared. You then actually do the multiplication and you subtract away, which is going to get simpler as we go along. That take away that disappears. This and this match up, so that take away this gives me 2a squared b, and I still have that 4ab squared, and I still have the 2b cubed. I haven't finished yet. I then see how many times will this fit into this one here. So a plus b going to here, I'm going to need a 2, I'm going to need an extra a, and I'm going to need a b as well. So this times this will match this, which means that I'm going to subtract it away. So 2ab times a is going to give me 2a squared b. I also have to multiply by the b, so that's 2ab squared. Subtract away, that disappears, which is lovely. This take away this gives me 2ab squared. I still have that 2b cubed to go. Hopefully that will disappear now. This, to make it look like this, I have to multiply this by 2b squared. 2b squared times this gives me 2ab squared, plus that times the b gives me 2b cubed. Excellent. So that subtract away gives me nothing. And I'm left with my quotient, my answer. So this whole thing divided by this is equal to this. And this process is the same process that you go through here. It's just that you don't necessarily always think about what you're doing. Let me show you another one. This time I am dividing this thing here. So I'm writing it in my sort of normal long division symbols. You can use your own if you do it different from me. But the principle again is the same. I move from left to right I see how many times this will fit into here. So to multiply this by something to get me this, I would have to multiply by a 4 and an x squared. 4x squared times x gives me 4x cubed, which is brilliant. So then I actually do the multiplication, this times this gives me 4x cubed. I also have to multiply by the -1, so minus 4x squared. Subtract away, that disappears. I'm subtracting away here, so be careful. Minus x squared, take away minus 4x squared. It's the same as adding 4x squared, because I am subtracting, which will give me plus 3x squared. I haven't dealt with the 8x yet. To make that fit into here, I have to multiply by 3x. I get 3x squared minus 3x. I'm also multiplying this by all of those two things. Subtract away, that disappears. 8 take away minus 3 gives me 11. The minus 11 comes down, and then that, to match that, I just have to multiply by 11, and it fits in perfectly. So this divided by this is this. This is my quotient, my solution. Let's do one more. Okay. Now this time I'm putting this underneath my symbols here. So 3x to the power of 4 plus 8x cubed. Now normally you would expect an 8x squared term here. There is no x squared term here. But when you're dividing, you have to include that, even though it's not included in your question. It's a bit like having, I know, 3,802, or actually 38,022, sort of. But there's a missing number there. We haven't got a 0 term, but I can add it in when I do this, because it's going to become important when I actually do the calculations. Okay, so working from left to right, this goes into this 3x cubed times. Subtract, that disappears, that take away that is nice and easy. This goes into this 2x squared times. And this is where the 0x squared is important, because I need to subtract something away from it. So that disappears, minus 4x squared. Then minus 4x plus 10. There we go. And that fits in perfectly. My handwriting doesn't work. So this whole thing divided by this can be found gradually. These are complicated things to do, and there's lots of difficulty, especially with minus signs. But my top tip is, if you don't have a term here that's missing, you have to add it in into your calculation, and take your time. Lots of practice. Good luck.